Today we're going to talk about isomers, which are compounds with the same atomic formula, meaning the same number of carbons and hydrogens, or heteroatoms, which are like oxygens and nitrogens and halogens, but they have different bonds, or you could say they have a different structure. So they're not bonded the same way, meaning that maybe they have a longer or shorter chain, maybe they have different branches. So we have a problem here on the left. It says determine all the structural isomers and names for C6H14. First, you need to understand what you're dealing with. So when you have C6H14, do you have an alkane, an alkene, or an alkyne? So you look at your carbons and you have 6, and you double those carbons, which would be 12, and in this case, you've added 2. When you double it and add 2, that means that it is a saturated hydrocarbon, meaning all single bonds. It's very important because if you have double bonds to move around, that actually complicates things quite a bit. So here's the technique or the rules of how to do isomers. First, you make the longest chain possible. So in this case, what I would have is a 6-carbon chain, right? I'd have 6 carbons all in a row, and that is as long of a chain as I can possibly make. And the name of that is hexane. Okay, you can't do anything else with that. If you move the first carbon to the second carbon, let's say, it's still going to be a 6-carbon chain, so that's not going to matter. So now what you do is you start to shrink the chain. So if you take 1 carbon off, you would make a 5-carbon chain. But then what do I do with this other carbon? So if I take this carbon right here, I apparently can't move, and I would move it onto the first carbon, then I'd have 1, 2, 3, 4, 5, 6 carbons again in a row, which is a hexane. So I can't have that on the first carbon. So I got to move it to the second carbon. So now I have a 5-carbon chain. So that is a pentane. And I have a methyl on my second carbon. So the name would be 2-methylpentane. Okay, what else can I do with the 5-carbon chain? Stay on the length of the chain. So I have a 5-carbon chain. Can I move that methyl to a different carbon? Well, you can't move it to the first, we just said, but can we move it to the right here into the middle? And if you look at it, yeah, that's on the 3rd carbon. So that would work as well. So that would be a 3-methylpentane. So now the question is, can I move it to this carbon? Could I have a 4-methylpentane? And if you're thinking yes, then you're not thinking about the rules of the branch having to be on the smallest number of carbon from either side when you're counting. So if I count this as 1, this is 1, 2, 3, 4, 5 carbons, but I could count it from this side, 1, 2, 3, 4, 5. Whichever direction I go, it has to be as a result of having the smallest number for a branch. So if I put this branch right here and I call it 4-methyl, you would be wrong because it's actually a 1,2-methyl. So that would be repeating this one. So I cannot do that anymore. So I have exhausted my 5-carbon chain. So I need to shrink my carbon chain to 4. If I shrink it to 4, now I have 2 carbons to deal with. So here's one example. And if I have 4 carbon chains right here, or 4 carbons in my chain, why don't I have a carbon on the 1st or the 4th carbon for my branches? And the reason why is that that would then be a chain instead of a branch. So right now I have 1, 2, 3, 4 in a row, or 1, 2, 3, 4 in a row. However I count that, it gets me to the idea that I have a butane chain and 2 on the 2nd and the 3rd carbons, methyls. So I say 2,3-dimethyl. Don't forget that you have to say the prefix of how many branches you have. Where else can I move those? Again, I cannot put it on the first. I cannot put it on the last. Well, what if I put them both on the second one, right? If I put them both on the second, I have not lengthened my chain. It's 1, 2, 3, 4, or 1, 2, 3, 4, and both those branches are on the 2nd carbon. So that's a 2,2-dimethylbutane. Can I make a 3,3-dimethylbutane? If you're imagining that they're here and here, then you again are forgetting the fact that I could start from this side and I could go 1, 2, 3, 4. So this is all I can do. This actually ends our isomers. And the reason why I know that is that if I reduce it to 3, see this chain right here? I already have 3. So that is not going to work. If I would have 3 more, let me highlight that once, and use it here, that would be my 3-carbon chain, and now I have an ethyl and a methyl and an ethyl, and that is the same structure as what I just created. So that is something that I'm not going to be able to make. So those are isomers. I have 5 isomers for C6H14. Same number of carbons, same number of hydrogens, just moved around with different bonds. Okay, so taking that idea, we are going to look at a much more complex structure. Reminder again, I'm just showing carbons. We assume that if a carbon's not bonded 4 times, then I have hydrogens bonded onto that. So I have 2 rules here. I wrote, find the longest chain that includes the extra bonds, okay? And then double and triple bonds are always found on the lowest carbon, number carbon. So we are going to start talking about a thing that we in Orgo kind of talk about priority in nomenclature. So there are certain priorities, and bonds get the priority in naming. So when you are doing a chain, the extra bond in the most simplistic nomenclature has to be on the chain. So here is my extra bond right now, right? So I have this extra bond here. And you have to realize that it has to be on the chain, because some people would go, okay, here's my chain right here. That's my chain. And I have 1, 2, 3, 4, 5, 6. Or you could be looking at it and go, well, maybe this is my chain. 1, 2, 3, 4, and then 5, 6. Regardless, that does not include my double bond. So I need that to include my double bond. So I need the longest chain that has the double bond. So I'm going to go 1, 2. If I go this way, I can't backtrack. So that's not going to work. So I'm going to go 1, 2, 3, 4, 5, 6. That would be the same as going up as well, because I have 1, 2 up here, and there's 1, 2 here. So that all works out really well. Okay? Now, you need to think about your branches. So here I have a branch, right? Here I have a branch of 1 carbon. And here I have a branch of 2 carbons. So now we need to name it. And the key to this is that we have to name it utilizing our lowest number possible. So if I want to do the lowest number possible, you either start on the top, the first carbon, or you start on this carbon, which would be the first for you as well. Well, if I start here, I'd say 1, 2, 3, 4, 5, 6. Or I start here, I go 1, and then this is 2. Oops. 3, 4. That's supposed to be 5. And then 6. I'm trying to use a highlighter here. So if we look at that, wow. I have carbon, a branch on the 2. I have a branch on the 4. I have another branch on the 4. So if we look at this now, it is very important to realize that if I have this is a methyl, this is a methyl, and this is an ethyl. Notice how I'm writing out the letters. And the reason why is that you have to put them in alphabetical order. So I have a methyl on the 2, I have a methyl on the 4, and I have an ethyl on the 4. E comes before M. So I have to say 4-ethyl, 2,4-dimethyl, hex, double bond, ene. So it's 2-ethyl, and that is extremely wrong. This has been typed in wrong, which is fantastic. Live and learn, right? So let's fix it based on my drawing. So I have a 4, and I got to do this all with the mouse, so I apologize. So it is actually 4-ethyl, 2,4-dimethyl, 1-hexene. And just so you know that that 1, when you have a double bond, doesn't necessarily have to be there. But we'll learn that as we go. So not the smoothest example, but it works using a mouse pad. Okay, last items here. 2 more examples. I want to make sure that you're understanding the differences with for bonds and numbers. So I have 2 examples here on the left. I'm not even hiding anything on you. You have a 4-carbon chain, and I'm calling it 1-butyne, or what I just addressed, it could just be butyne. If there's no number for the bond, then you assume it's on the first carbon. Okay? The second one, the carbon, that is 2 and 3 is holding the double bond. This has to be number 2. If you start from here and you say 1, 2, 3, 4, or 1, 2, 3, 4, it doesn't matter. But it's 2-butene, you need to have the 2 because it's not on the first. Very important. Okay, final thing. If you'd like to pause it or whatever, try to figure out what this is. So pause the video for a moment. Find the longest chain that involves the double bond. I was not trying to make it horribly tricky, but I'm going to highlight it. So I believe it's right here. And I wanted that to be a lot nicer than that. So let's try that one more time. Let's make it a little thicker. So now the key is to make sure you are understanding where the numbers are. So I have a branch. Here's a branch. You don't have to do this, but it does show you what's happening. And I have my last branch. All right. Is this carbon 1 or is that carbon 1? Well, first, let's just make sure that we've counted this right. So I have 1, 2, 3, 4, 5, 6, 7. I have 7 carbons. So if I call this number 1, I go 1, 2, 3, 4, 5, 6, 7, or the other way, as I just said. If I do this, this is the trick. I say 1, 2, my branches are on the second carbon. I say 1, 2, 3, my branch is on the third carbon. You know what? That doesn't matter if there's an extra bond unless there's a tie. The bond gets the lowest number. So if I go this way, I go 1, 2, 3, 4. If I start the other way, I get 1, 2, 3. Oh, that's the winner. So this is 1. I'm just going to go to 3. That's a 3. Okay? So 1, 2, 3, 4, 5, 6, 7. So now let's quickly talk about what we did again. This is a methyl. This is a methyl. This is an ethyl. And this is a methyl. So what comes first? It has to be the ethyl. So when I'm doing this, it's got to be 3 ethyl, 2, 2, 5 trimethyl. What do we have? What did I say? 7. And then I'd say where the carbon is 3 heptene. I believe that's what it's going to say. So here's my 3 ethyl, 2, 2, 5 trimethyl hexene. Very important that you're understanding that this M right here and this E is in alphabetical order. Okay? And that's how we're going to do that. So I gave you some different problems on Orgo 2, and I'm actually handing out Orgo 3 as an extra thing to start working on because it shows a lot of these problems. I would like you to box the chain if you can, and then circle those branches and start naming structures if you can. And then we'll continue this on the next day.